So hello everybody, my name is Ingo Meyer-Knoch from weTHINK here for the first podcast of our weTHINK Waste Circularity working group that we would do together with IWWG. And today the topic is going to be thermal treatment. And very happy to have Marco Ryskowski from the Technical University of Hamburg doing a short introduction about the cooperation, the working group, weTHINK IWWG, and the topic in general.
Thank you, Ingo. Marco Ryskowski here, Managing Director of the IWWG, the International Waste Working Group. The International Waste Working Group is a worldwide operating scientific-oriented network. We have members from about 50 countries worldwide. And we are acting in the field of sustainable waste management since 20 years. So this year is our 20th anniversary. And we came across weTHINK just this year. We learned about it through one of our board members from Austria. And we found that both groups perfectly complement to each other, since weTHINK.eu is having a strong focus on networks, including industrial partners. And we are very much academic-based and scientific-oriented. So the idea was that the collaboration between these two organizations could be beneficial for both sides. And during the discussion about this collaboration, we decided to produce a series of podcasts. And here we are with our first podcast, organized by one of the task groups, which IWWG is organizing. And this is on thermal treatments. So Lidia and Professor Umberto Arena are the leaders of these task groups. Please go ahead.
So thank you very much, Marco. Thank you. I want to thank weTHINK and IWWG for this opportunity. As you said, my name is Lidia Lombardi. I'm an associate professor in energy systems and environment at Cusano University in Rome, and I have the honor to co-chair the thermal treatments task group, whose leader is Professor Umberto Arena from Italy. He is one of the today's speakers. Hi, Umberto.
Hi.
He is a full professor of solid waste management and industrial pollution control engineering at the University of Campania, Luigi Vanvitelli, and is co-editor-in-chief of the Waste Management Journal since 2018 and a member of the managing board of the IWWG. And his research interests are related to thermal treatment of waste. But we also have three other speakers today. All the speakers in some way are linked to the task group working on thermal treatments of the IWWG. And let me introduce the other speakers for today. I'm very honored to welcome Marco Castaldi from United States of America. Hi, Marco.
Hello.
Marco is a professor of chemical engineering at the City University of New York, at the City College campus, where he is the director of the Earth Engineering Center and the head of the Waste to Energy Research Technology for US. He is a technical fellow of the American Society of Mechanical Engineers and the American Institute of Chemical Engineers, and he is a Fulbright Global Award Fellow. Then it's my pleasure to welcome Christophe Cordon. Hi, Christophe.
Hello, everybody.
From France. I would say bonjour, Christophe.
Ciao, ciao, Lidia.
Ciao. He's an engineer with more than 30 years of experience in the environment and renewable energy industries, especially in waste management, pollution control, and energy transition. And he was a former Deputy General Manager for Lab SA and Development Director of CNIN Group. Is the Vice Chair of the Working Group Energy Recovery of the International Solid Waste Association. And in 2022, he created his own consulting company named WasteTT that stands for waste thermal treatment. And then I'm happy to introduce the fourth speaker for today, that is Massimiliano Materazzi from UK.
Hello, everyone.
Nice to see you, Massimiliano.
Nice to see you, Lidia, and everyone.
He is a Principal Research Fellow of the Royal Academy of Engineering and Associate Professor at the University College in London. And he has worked for over 10 years in the waste-to-energy industry, and presently is a technical advisor to the company Advanced Biofuel Solutions, collaborating on two major projects funded by the UK government for hydrogen production and hydrogen production from waste and CCS. So let me thank you very much for being here today to discuss about a topic which is the expected role that thermal treatment plants can play in a modern waste management system. So let me clarify that today we would like to focus specifically on thermal treatments for municipal solid waste. Thus, the stream we are looking at is the mixed, or we call it residual municipal solid waste. That it is what is left downstream a correct separate collection system of different recyclable materials, and thus the stream we are interested in it contains non-recyclable materials. So first of all, I would like to collect your short opinion about the current state of technological reliability and environmental sustainability of present thermal treatments for this stream. I think we can have a first round, very short comments about this first part from each speaker. Maybe we can start from Professor Arena.
Thank you, Lidia. Very fast. I believe that the thermochemical treatments of different kinds of solid waste are today able to provide an efficient and safe recovery of electric and thermal energy and improve the recycling of inorganic material from the bottom ashes, a crucial saving of space for landfilling. All this is obtained in Europe and in the rest of the world in full compliance with the protection of the human health and the environment. It is also noteworthy that, as recently highlighted by a study peer-reviewed by Professor Thomas Christensen of the Technical University of Denmark, the thermal treatments already reached the status of a substantially climate neutral sector. But there is a new challenge now to move from this status quo of a climate neutral sector to a new status characterized by further improving of environmental performances in terms of global warming potential. That means able to obtain a negative CO2 emission balance. The target of a carbon negative sector can be achieved, in my opinion, and I would like to know the opinion of other colleagues, by innovative system of post and pre-combustion capture of CO2. The first type are devices of carbon capture and sequestration, which will be gradually coupled to the conventional waste-to-energy plants. The second type is the series of steps that characterize or can characterize innovative waste-to-fuel processes and technologies.
Thank you, Umberto, for this first comment. I think we can go more deeply into these topics later on, but first I would like to listen to the opinion on the current technologies from Christophe.
Yes, thank you very much, Lidia. This is very important, yes, to make a first, let's say, state of the art of today's technology. And for sure, we have now a very reliable technology especially for one very important key task of the thermal treatment, which is the hygienic task, the sanitary service, because we need to have a sink for the pollutants. We need to have a sink for dangerous organic contents of our waste, which are non-recyclable. And this is the only solution for that is the thermal treatment. During COVID-19 pandemic, we have seen the very important role of waste to energy to destroy this type of components. And we have forgotten this hygienic task of waste to energy, often promoting more the energy from waste part. But I believe this is a very important and key task in the waste treatment. And the only other solution is landfill for disposal. And of course, landfill, as Umberto has just said, has a very important default, which is the climate change impact. Another very important point in your question is the environmental sustainability. Linked to this sanitary task, of course, waste to energy now with flue gas treatment evolution and performances has managed to have really environmental sound way of treatment with very small impact on environment and human health, and also on climate change. And therefore, we can produce local, baseload, non-intermittent, renewable energy based on the waste to energy facilities. So today, I really believe that we have reliable technologies and sustainable environmental way of treatment of the waste based on waste to energy or energy from waste technologies.
Thank you, Christophe. What do you think about this, Marco, about conventional thermal treatments, current technologies?
Thank you, Lidia, and everybody for the opportunity to give the U.S. perspective. I say hello to you from New York City here, and so you may hear some outside activities that are always present. In the United States, currently, most of the thermal treatment technologies are dominated by mass burn controlled combustion systems. There are 76 waste-to-energy facilities in the U.S., and they process nearly 94,000 tons of municipal solid waste per day, and producing enough energy to power nearly 2.3 million homes. And in the United States, there's a very strong focus on the connection to the health impacts, of course, as well as to the environment. We recently had the opportunity to review several dozen peer-reviewed studies from around the world, and the vast scientific peer-reviewed literature demonstrates there is no health risk impact of operating proper waste-to-energy facilities in the US and worldwide. This includes aspects of asthma, infant mortality, blood dioxin levels, and carcinogenic effects. And also, importantly, the proximity to a waste-to-energy facility did not change those findings. In fact, more health risks were associated from local traffic patterns that contribute to ground level NOx, ozone, and particulate matter. So it's important to recognize that the performance of waste-to-energy facilities and thermal facilities are always improving. And therefore, one cannot rely on outdated studies and information to make decisions of using these facilities. And we must continually review the most updated information to make the best decisions, especially in the United States.
Thank you very much, Marco, for this information synthesis. I think we can ask also Massimiliano Materazzi what is his impression or opinion about current technologies for thermal treatment.
Yeah, thank you, Lidia. I'll try to give you a little bit of a perspective from the UK scenario, which of course has many things in common with other countries. So first of all, I would just like to iterate that despite the best efforts in boosting recycling rates and diverting part of food waste or biomass to anaerobic digestion plants, there will always be a substantial amount of waste that needs to be safely and sustainably disposed of, and for which at the moment thermal treatment really represents the best choice. So this is just to emphasize how important is this. Now in the UK, as globally, the scenario is pretty much similar to what Marco has just presented. So thermal technologies for disposing of waste are mature, with multiple units for mass burn incineration using moving rate, for example. At the end of 2021, there were 50 to 60 fully operational waste-to-energy plants in the UK. Just to give you an idea, the total permit capacity of these plants is around 20 million tons per year. So it's quite a huge amount of waste that's been disposed of. Now, if you think that these plants would collectively emit around 20 to 25 million tons of CO2 equivalent per year, you can also understand how big would be the gain if we were able to also capture that carbon with normal or new thermal technologies, and therefore provide opportunity for not just carbon neutral, but potentially even carbon negative technologies. I think this is a very key element of these discussions today. And finally, just to mention about other thermal treatment technologies like gasification, for example, these are less proven. It is a fact that these have been established for energy or heat production. When it comes about fuel production, it's a different story. There are few demonstration plants under commissioning, or some early plants under commissioning operation. So in this sense, the next couple of years will really be critical to understand the future of thermal technologies, also for sustainable fuels production.
Thank you very much, Massimiliano, for starting this topic. I mean, we started from conventional thermal treatments, and I thank all of you for this first round of opinions about the conventional thermal treatments. But now, yes, what we would like to do is to try to look a bit farther. And my further question is about your opinion about the future perspective for thermal treatments, as you were anticipating. So again, in relation to the mixed residual municipal solid waste, what do you think that in the future the thermal treatment will be? The possibility to produce fuels was already anticipated. The possibility to have CO2 capture was already anticipated. So let's focus a bit more on this future for thermal treatments. I would ask again kind of a round of opinions from each of you. And really, I would like again that you can focus on your specific area of interest, both focusing on the technological aspects of your area of interest and also on the geographical interests. So I think we can start again from Umberto, and maybe he can further explain the different pathways that we can follow for the new role of thermal treatment in the future. So maybe explaining a little bit more about the topics you already anticipated about CO2 capture and fuel production, chemical production. Umberto, please.
Thanks. I believe all of us already mentioned that the old role of thermal treatment is able to provide energy materials in full compliance with the protection of environment. And this role is today, as Christophe already mentioned, absolutely crucial, probably more than in the past due to the increased amount and complexity of the residues. But I absolutely agree with Massimiliano that there is also a new role for thermochemical treatments which should be considered and implemented as soon as possible. It includes a remarkable reduction of direct emission of greenhouse gases and the sustainable production of hydrogen, methane, and drop-in fuels. With reference to the first point, it is clear that the production of energy in the waste-to-energy units or fuels in waste-to-fuel units necessarily imply a production of CO2. Moreover, power is required to drive many key components of the system, and then it will not be possible to achieve net zero emission of CO2 by using these technologies unless CO2 is captured pre or post combustion and low carbon electricity used to power this system. As Massimiliano already said, the target is to transform an almost carbon neutral sector to a carbon negative sector. The conventional waste-to-energy sector is mainly looking into carbon capture and use or storage unit as an extra but effective tool to further reduce its carbon footprint, with the possibility to reach net negative CO2 emission. This aspect could be crucial. There is a recent report in last April of a United Nations IPCC group that indicates that in Europe only, the integration of carbon capture sequestration with waste-to-energy facilities has the potential to capture about 60-70 million tons of carbon dioxide annually. And there are really interesting examples of this option in the Netherlands, in Duven, close to Rotterdam, and in Norway, Klemetsrud, closer to Oslo. But in my opinion, the sector of thermal treatment can do more. Let me say something more about the second point I mentioned before, that of the production of hydrogen, methane, drop-in fuels. This is a technology feasible option close to the commercial status, mainly by means of the gasification processes that has been already mentioned. Most of you knows that gasification is characterized by a number of endothermic reactions in presence of a gasifying agent as oxygen, steam, or CO2. The resulting fuel gas contains large amounts of not completely oxidized products, which can be utilized in different sites, different times, and different applications. This means that the gasification, which is a relatively young process when applied to solid waste, has a very wide versatility in input and, above all, in output. It can be carried out in autothermal mode, just by using part of the chemical energy of the waste to provide the energy required by endothermic reactions, or in allothermal mode, just by using an external source to provide this energy, so saving the original energy content of the waste. Both these gasification types, I recently made a recognition of this technology for another initiative of IWWG group called Food for Brain, a series of interesting webinars. And I discovered that there are both allothermal or autothermal gasification processes able to produce hydrogen, methane, or drop-in fuel. Obviously, the syngas must be rigorously cleaned. This is a crucial point, the syngas cleaning aspect. And then appropriately conditioned in a series of adjustment steps, in particular to reach an appropriate hydrogen to CO ratio. This will allow to utilize the obtained, cleaned, and conditioned syngas in the synthesis of chemicals as methanol or ethanol. I hope that Marco Castaldi will give us some information about interesting initiative in Canada, or the production of hydrogen, as I hope also Massimiliano could give us some interesting news. The crucial aspect to conclude my contribution is to have a very high quality syngas. This imposes to remove a wide range of contaminants. This refined syngas must be compressed to deliver the syngas to the high pressure required to the syngas upgrading and fuel synthesis equipment. All this series of step processes can be called the pre-combustion CO2 capture. The main driver for this application is the climate change and the agreement of the majority of countries to phase out fossil fuels. Then, in my opinion, this could be the true, really innovative new role of thermal treatments in the next future.
Thank you, Umberto, for these explanations of the two possibilities that you see in the future for the thermal treatment role. So we will try to go more in details for both the possibilities. And maybe first we start from new waste-to-energy plants with or without CCS. And maybe I think Christophe can comment about this. What is your idea? Is it possible that carbon capture and storage is applied in the near future, let's say, to waste-to-energy plants? I mean, we are talking to apply it to conventional power plants since more than 20, 30 years, and only few applications are around the world. So what could speed up the process in the case of waste-to-energy?
Thank you. Sorry for the mute. Yes, thank you very much, Lidia, for this very interesting question. Yes, I believe it's possible technically to have carbon capture on standard conventional waste-to-energy facilities. I believe it's mainly economically an economic problem to solve now, to have the diffusion of this type of technology on waste-to-energy. But as it has been said by the International Energy Agency recently, there is the highest economic benefit to have carbon capture on waste-to-energy with an optimal greenhouse gas mitigation and energy potential. And this is on our sector. It's, let's say, it's not an hanging fruit, but not very far from it. Nevertheless, I believe first that there is a big elephant in the room for greenhouse gas emissions in the waste sector. And this big elephant, or bull in a china shop, is first the methane emissions from landfills. Because today in Europe, we have almost 100 million tons of CO2 equivalent, which is emitted by landfills. And we don't have so much open dumps in Europe, so we have already sanitary landfill. But nevertheless, with the methane emissions of these landfills, we have a huge amount of CO2 equivalent of greenhouse gas emissions coming from these landfills in Europe. And for me, the first step would be first to close these landfills. And this is the objectives in Europe, which has been given by the circular economy package, to reduce landfilling down to 10% in 2035. Nowadays, we have almost 100 million tons of non-inert material going to landfill in Europe, giving this 100 million tons of CO2 equivalent. And this is the first step. And we see in Europe, I believe like in US, for example, that we have huge differences country by country. Of course, some countries in Scandinavia, they have almost zero landfill. But a country like Spain, for example, they have 56% of their residual municipal waste going to landfill, with this impact on greenhouse gas emissions with the methane. And nowadays, we see first with the COP26 last year, and even Ursula von der Leyen has said that methane is one of the gases we can cut fastest. Because, for example, on waste sector, it's really easy to cut these methane emissions. And in the COP26, they have decided to reduce by 30% the methane emissions. And nowadays, we are starting to speak about methane. And I remind you that methane is 86 times more, have a global warming potential 86 times higher than CO2 on a 20-year perspective. So for me, this is the emergency. The emergency is to reduce and to mitigate landfill. Second point, as you have said, and as Umberto has declared, waste to energy today is carbon neutral because of the energy production and the material recovery. The CO2, which is emitted during combustion from fossil fuels like plastics, are in fact reduced by the energy substitution that we offer with energy production. So today, waste to energy, as has been shown by a recent study from Prognos, is carbon neutral without any carbon capture. And of course, if we install carbon capture on waste to energy, as there are many projects today in Europe, we can be carbon negative. So in fact, to reduce CO2 from the atmosphere with the help of this type of technologies. And there has been an evaluation if 50% of a waste to energy plants would be equipped with carbon capture in Europe, with 90% reduction of CO2. Therefore, 40 million tons of CO2 could be captured, let's say, in the atmosphere, and with this carbon negativity of waste to energy. So this would be this would have a very high and very positive impact on climate change. And this is quite an hanging fruit, quite an easy job to do that, because technically the solutions are there. They are very good pilot plants, and today they are not only pilot plants, but the first commercial plants which are installed, especially, for example, in Duiven in Netherlands, where they have carbon capture on the waste to energy, and they use this CO2 in greenhouse for the production of tomatoes and vegetables and so on, replacing a gas burner by the CO2 which has been captured in waste to energy. There is another project in Twente also, which is under construction to capture 100,000 tons of CO2 on the existing waste to energy plants. There are projects in Oslo waste to energy plants, in Copenhagen waste to energy plants. In UK also there are some projects to install carbon capture. Of course, one of the main difficulty is linked to the small price of CO2, and therefore the economy of a project is difficult to start. But with the help of the European Commission, and I believe they have in mind to the reduction of CO2 emissions and methane emissions, I believe this could start quite easily. To conclude, also there are also some projects on these plants, and I remind you that 100 million tons of municipal waste today are treated in conventional waste to energy plants in Europe. On these plants, it's also easy and possible to produce fuels, such as hydrogen. We have the example of a plant in Germany, in Wuppertal, which is producing hydrogen from the waste through, of course, electrolysis. But it's also, there are also other projects of waste to fuel. There is a project starting in Finland named Carbon to X, with waste to energy plants, and then production of hydrogen, recovery of CO2 from carbon capture, and then combination of these two elements to produce methanol or fuels from these two elements. There are other projects in Europe around this type of technologies to have synergies between waste to energy and energy to fuels and carbon capture. So I really believe that there are a number of synergies and possibilities for all this combination. But of course, we will need the help of the public institutions to start this type of business, because today the CO2 price doesn't allow the direct financing of this type of projects. Thank you.
Thank you, Christophe. I fully agree with you when you say we have this big elephant there and we have to throw it away. So first solve nowadays problem, especially in those areas where there are no type of plants. I mean, yeah. we are discussing here which type of plants, but there are some places where there are no plants and things will go to landfill. So yes, this is the first step. But yes, the synergy that you are mentioning to produce electricity and fuels, maybe it is interesting. Yes, in the future when energy could be less attractive, electric energy, for example, could be less attractive because we are going toward increasing renewable and electricity mix. So producing electricity could be not so interesting, and maybe the fuel production could become an interesting one. So in this view, maybe we could have some more information and description about I think we can ask Marco to tell us about the only existing commercial plant today in the world producing some chemicals from waste. Marco, can you give us some clues about this?
Yes, thank you, Lidia. And I thank Umberto and Christophe for setting up this position. I will give you some perspective again in North America. And really the movement is to look at these, what we call in the United States, advanced thermal treatment technologies, or many times what is called advanced recycling technologies, because it manages the stream that is the residual of the waste stream after all of the economical recyclables are removed. And there is starting up a lot of pyrolysis plants, but these are just starting now and they're getting a lot of attention. However, as you mentioned, Lidia, there is a facility in Canada. There are actually two facilities in Canada, Enerchem, And we were very fortunate, again, to work with Enerchem over the years to understand their processes. Very briefly, the Enerchem facility is in Canada, and it has a pilot facility, two pilot facilities and one commercial facility that is targeted to make 10 million gallons of what they call biofuel, which is primarily methanol or ethanol per ton of MSW that is processed. And the commercial facility that they have in Canada now, just to give an idea, is processing 300 tons per day of MSW. They have plans to expand two other facilities, one in the United States and one in Europe, but that has been slowed down a little bit by the pandemic. However, it has not stopped. So what about the study that we did to give an idea of the amount of methanol? And what we focused on was that it would not be possible to obtain a 100% biomass or bio-based waste stream that could be processed in these facilities. What was recognized was coming from material recovery facilities and other streams, there would be a mixture of bio-based, of course, renewable materials that are in the waste stream, but there will still be a residue of plastics that cannot be recycled or will not be recycled. And so we embarked with them on a large-scale test where we were processing in their pilot facility 8 tons per day. And we looked at 4 different tests. One that was 100% biomass, so we specifically made that material. And then we increased the amount of plastic in the biomass, in the waste stream with biomass, 8%, 15%, and 50%. And I'll just give some highlights and details about the data that we generated from this facility. Again, we were on site. We worked with them to have a continuous feed system that they were able to continually feed the gasifier. And then downstream from the gasifier, they had a synthesis gas cleanup. And then from the synthesis gas, after they cleaned it up, they brought it to a methanol synthesis island. And again, we were able to take measurements all throughout there. So the first thing that we wanted to understand was what was the impact of these non-recyclable plastics in the stream with the biomass. And to give you an idea, we looked at a number of different components, but I'll only focus on 2. The hydrogen to carbon ratio and the heating value of the stream, because for gasification to go to chemicals, both of these things are important. So first, the hydrogen to carbon ratio. The 100% biomass stream that we had a hydrogen to carbon ratio just under 1. But as we added 8%, 15%, and 50% plastics, that hydrogen to carbon ratio increased from about 1 to 1.10, 1.15, and 1.2. So this made sense that as you add the plastic, you increase the hydrogen carbon ratio. Now I'll focus on the results from the comparison to the pure biomass and the 8% and 15% streams. Because the 8% and the 15% streams increased the heating value that was commensurate with the amount of plastics. And of course, as there were more plastics into the stream, what we saw was that the ratio of carbon and hydrogen that went into the synthesis gas compared to the 100% biomass stream increased as the plastics increased. So the 8% plastic stream gave about a little bit more than 1.5% more than the typical biomass. However, the 15% plastics resulted in 40% more of the hydrogen and carbon in the synthesis gas. So what does this mean? This means that it is now more possible to produce more fuels because we've got more of that solid carbon and hydrogen that went into the synthesis gas that can go and make, in their case, methanol. So for example, if you take the baseline value of methanol produced from biomass as 1, that with the 15% plastic in there, they were able to produce 20% more methanol. And with the 15% biomass, they were able to, plastic in the biomass, they were able to produce 40% more. So as expected, as the plastic into the biomass stream or the residue plastics that would be found in the waste stream increased, there would be the potential to produce, and we actually measured it, to produce more of these fuels. 20% more in the 8% plastic case and 40% more in the 15% plastic case. Now, the efficiencies, of course, increased. The efficiencies with plastics went up by 10% and in fact 2 times the thermal efficiency. And this is related to the heating value. So interestingly, when we had the 50% plastic in the biomass stream, so imagine a waste stream that did not do a very good job of removing the plastics, or there's just no market for the plastics, and 50% of the residue stream leaving a material recovery facility has 50% plastics in it. The stream that we tested, of course, had a higher hydrogen to carbon ratio of 1.2, but the heating value happened to be between the heating values of the 8% and the 15% streams. And what did that result in? What that resulted in was the amount of methanol produced from that stream matched the amount of methanol produced with 15% plastics. So even though the hydrogen to carbon ratio was higher, because the heating value was a little bit lower, the amount of methanol that was produced was a little bit lower. And in addition, the efficiency of the system, the overall thermal efficiency, using the 50% plastic stream was about 1.6, about 60% more efficient than pure biomass. But that was between the 8% and the 15% stream. So I'll sort of summarize that in making fuels from gasification systems, the hydrogen to carbon ratio is very important because that will determine the ultimate fuel mix that you can make. But it's not just the hydrogen to carbon ratio, it's also the energy value that's in the gasification system, because that will ultimately end up in how much gas can be made, cleaned, and produced to fuels, and how much, say, tars and chars are left over that cannot be gasified. So while conceptually it sounds simple, that if you just increase the amount of hydrogen to carbon in a waste stream and gasify it, you can make fuels and just project forward, there are some, what I would call complexities. Heating value is one, moisture content is another, and finally, of course, any non-combustibles that you have, glass and metal and so on. These will impact the performance of the gasifier. So in summary, I just stop here to say that, of course, these gasification systems work. The commercial facility in Enerchem is producing methanol at the rates that I told you, but the operation of these gasification systems is very specific to the fuel mix, the hydrogen to carbon ratio, and the energy content. So thank you.
Thank you. Thank you very much for reporting your direct experience about this. It is really interesting. Yes, the probably not very important point is the quality of what you put inside. And I think the same experience can be also discussed by Massimiliano for another kind of product, very interesting product, which is hydrogen produced from waste. Which is your experience about this?
Yes, thank you, Lidia. Before that, let me step back for a moment just to explain what the UK situation is, because that will help a lot in kind of understanding what the key drivers are for technological choices in the coming years. So situation is quite complicated in the UK. So dealing with waste has its own challenges, which are not just technical, I must say. So for many years, the UK have been exporting waste to Europe. Okay, in 2017, the UK were exporting 3.2 million tons of refuse-derived fuel or solid recovered fuel to Europe. This quantity has halved in the last year. So this can be associated to many reasons. It can be partially due to the pandemic, because the pandemic has heavily affected the commercial activities, which obviously results in a lower amount of waste generated, but also, you know, new taxes that have been introduced in the continent, especially in the Netherlands and in the other countries where UK was exporting waste. On top of this, there are also new waste facilities coming on in the UK that became operational in the last few years. And this obviously has increased the domestic treatment capacity available in England. Then there are other factors. Brexit is one, which obviously has reduced inward investments from Europe and has changed completely the supply arrangements. And finally, not least, there is the current energy policy, which is responding to, you know, security and affordability and sustainability of UK's energy supply, and that's associated to the cost of the rising cost of gases and you know, the war situation and so forth. So this has set some key priorities in the UK that were issued in last April by the 2022 Energy Security Strategy, which basically identified what the future focus energy supply will be. So this will be largely dominated by offshore wind, with some onshore solar photovoltaic, nuclear, but very importantly, there will be a major role for hydrogen and sustainable fuels. So hydrogen in the short term, it is envisaged it will coming mostly from what we defined as a blue hydrogen. So reforming of North Sea gas with associated carbon capture and storage. And the reason why I'm mentioning this is because the whole carbon capture story, it's very nice, but he has to come with a development of infrastructure of carbon dioxide. And this is very important. And this is how this is rapidly building up in the UK, because not only waste to energy facilities and hydrogen production, but we also have these CCS facilities coming up with other technologies. I mentioned blue hydrogen. The second thing are sustainable fuels, especially to decarbonize those sectors which are very difficult to be decarbonized, which are transport. And when I say transport, I'm talking about those transportation sectors which are difficult, like aviation. And you might have heard very recently about, you know, these sustainable aviation fuels coming from waste, which is certainly one important focus in many countries, and heating. And that's where the whole focus of my recent research and industrial development with industrial partners. I'm here also on behalf of industrial partner ABSL on the biomethane and bio-SNG generation. So just to differentiate for those that are not too familiar, biomethane is typically defined as the methane that comes from anaerobic digestion of biomass waste, basically. Bio-SNG, synthetic natural gas, is still methane, exactly the same molecule, but is synthesized from syngas generated from gasification. So therefore, you can kind of accept a much wider range of feedstock by thermally treating it. And that's one of the most important strengths of thermal technologies, in my opinion. Now, The ABSL approach, the Advanced Biofuel Solution that I'm working with, is basically proposed a two-stage approach to deal with waste. Waste, as Umberto, Professor Arena has briefly summarized, has two major problems when dealing with waste and gasification. One is tars, and the second one is the ashes, which obviously is much more abundant and much more complicated than when you compare this with pure biomass or other types of technologies. So having a two-stage approach, like in this specific case, is a fluidized bed gasifier, and that separates then plasma converter to deal with the ashes and the tars on purpose. That kind of provides that flexibility that is needed when dealing with waste feedstock. The gas, which is then free of tars, needs to be further cleaned to get rid of other contaminants like chlorine, H2S, COS, SO2, and other light hydrocarbons. Then this syngas goes to further catalytic treatment to both reduce contaminants to PBB levels, and that's simply because all catalysts for either hydrogen production or for fuel generation are super sensitive to contaminants. So that's why it's very important that you reduce these to very minimum levels. And at that point, it's all about the choice of catalyst. Depending on whether you use a nickel rather than an iron-based catalyst, you can tailor your process to produce synthetic methane or just pure hydrogen, really depending on the operating conditions. Now, for the introduction which I made at the beginning of this intervention is that since infrastructure is very important and the decarbonization of heating is one of their priorities in the UK, that's why it's driving the choice towards synthetic methane. Because you can make use of the existing infrastructure. You don't need a new infrastructure to store the fuel or to transport it. And you can gradually and progressively decarbonize one of the most polluting sectors, which currently rely on entirely on fossil fuels. New developments are ongoing then to steer towards hydrogen. The ether from methane to hydrogen is very natural, simply because hydrogen can be in part used for heating as well, just by mixing with the current gas system. But in the future, can be fully replace methane in its use, whether it's for heating or transport. And the second big advantage of hydrogen is obviously you maximize the amount of carbon that you can remove, because you don't end up with carbon in the final fuel or molecule, but the entirety of carbon initially present in the waste feedstock can be captured and either used or permanently sequestered. So hydrogen and biohydrogen specifically offer the greatest carbon removal capability for new advanced technologies in the coming years. And as with regards with ABSL, currently they are commissioning this plant in the UK that will treat approximately 8,000 tons per year of waste to generate 2.2 million cubic meters of bio-SNG, and that would be enough to, just to give you an idea, to provide heat for 1,800 homes or fuel 75 heavy good vehicles. So it's a quite substantial and interesting demonstration, which hopefully will start operation in the coming months. And the plus bonus that you have is that you end up with a ready to sequester CO2, which in the ABSL plant is removed by a benefit process, and that can be used for permanent sequestration or even for use in industry, because let's not forget CO2 is also chemical feedstock for many industries, and can be found some good use while we're waiting for storage infrastructure.
Yeah, thank you, Massimiliano. I think, yes, the point is, again, we have to remove and capture this CO2, and probably we can make another podcast about how much CO2 we need in the world and how much we are going to produce if we remove from all the waste treatments and so on, but this is another point. So I think this is a very interesting point from the UK, so a little bit different from the others. I think we already took a long time, so I would have another point to discuss as a very short comments from you all in another round, but I don't know if it's the case, because of course I'm very happy that there are possibilities, concrete possibilities, that gasification can be used and valuable products can be produced as bio SNG or hydrogen or chemicals. The point, and also that CO2 can be captured maybe from conventional waste to energy plants. But one point, actually 2 points are, I think, to be discussed very shortly. Just one comment from each of you. Reliability and cost, because we are working with waste. So these 2 points are very important. Please, can you really give just very, very short comment about this? I see Cordon, Christophe is already on the way of talking about this.
Yes, thank you very much. I think it's the key point, because of course we should compare, for example, the production of hydrogen from waste with conventional system together with electrolysis, sorry. We should compare the cost of that and the reliability of this system. We should compare it to alternative technologies with gasification, for example, and we should compare the reliability. The first one, we have reliable technologies, existing and mature technologies for waste to energy, and then for production of hydrogen or production of methanol, or even for carbon capture. Carbon capture is less mature for the moment, but technically this is not a huge problem. And we should compare the cost of this solution to an integrated or to a thermal system producing directly methanol, as Marco Castaldi has explained, or Massimiliano in UK, or hydrogen. And this is the cost who will make also the choice. And as you have said, Lidia, we are talking about waste. And waste is very variable. We don't control what is in the dustbin. And we have evolution. Marco has emphasized the problem of hydrogen and carbon ratio, and show the impact of plastic composition in the fuel for the in the process in US. But in fact, for example, this plastic ratio should decrease normally in Europe, because we should have higher recycling of plastic. This is promoted by EU, and therefore this would have an impact, very important impact on the process of such technology. And one of the main interests of conventional technology and mass burning is that it is adapted to this waste variation and to waste evolution. And I think we should not forget this very important point.
Thank you. Thank you. Umberto, what do you think about reliability?
I believe that the problem of reliability is relatively related to the gasification process. The problem is mainly concentrated to the syngas cleaning unit, which must work well, work continuously, work in a rather simple and economic way. That's the crucial point. I mentioned a couple of times that the journal that I'm editing, the Waste Management Journal, I proposed a couple of times some special issues about syngas cleaning, and never we received papers. It is absolutely unbelievable, because it's a journal that is completely full of requests, in particular for special issues. It is an area where there is a lot of confidential information. Everybody is working on, but nobody wants to tell the other about the progress. It is a crucial point. It is the point that can give or not the possibility to gasification to transform or in part to transform the market. We now know that if we wanted to produce energy, there is no competition with the combustion process, only for very small size. So if the future is to produce chemicals or hydrogen, it is necessary to achieve as soon as possible reliable and economic way to clean the syngas. I hope that we have the opportunity to discuss more in another podcast as this and in other IWWG initiative about some progress, specifically on syngas cleaning. If we are not able to make a special issue for the journal, we can organize a podcast about the syngas cleaning.
Yes, thank you. Very crucial point. So just two comments from Marco and Massimiliano. Massimiliano, the project that you were telling us, is it in some way subsidized by the UK government? And in case of Enerchem, Marco, can you make any comparison? I know prices are really different from US and Europe, but do you have any idea of the feed-in tariff for waste in the case of Enerchem? Massimiliano, you can start.
Yeah, so I think that's very important, and most these kind of innovative advanced thermochemical technologies, they always relied on the on the gate fees and the negative cost for the feedstock, which obviously will not always be the case, right? Because in an hypothetical future where all this technology will be working together and waste will be seen finally as a resources and not as a waste, they will not have a negative value anymore, and therefore the market will be completely changing. So it's important that these that we use the current incentives from the government and from and mechanisms from the market to test these technologies, scale them up, because the only way by which cost can be reduced is by accumulating operational experience, and therefore design and build plants that will be always more efficient and less costly. And that's been what basically has been proven to work very effectively with other green technologies, like if you think about solar or wind farms. So I think that's a very important factor. The second important factor that you mentioned, Lidia, is obviously the help from the governments. Just to give you my personal examples with ABSL, the plant has been largely funded by the government and subsidized by the government, because obviously very few investors would approach and risk their money on funding something that has not been proven yet, and that's totally understandable. So it's important that the government step up and trying to bridge these big gaps that we have from small pilot facilities and profitable and large enough commercial appliances. So the combination of the two really is what is needed here to drive the costs down.
Thank you. Marco?
Yes, thank you, Lidia, for this last opportunity. As you mentioned, the situation in the United States, particular, and somewhat in Canada, very different. The energy prices here, although are a little bit high now, are historically very low. And in the United States, it is completely driven by the economic situation. There is very little investment by the government, whether it be at the local or the national level, to subsidize these facilities. And so, as you know, the United States still landfills nearly 50% of its waste. And this is purely driven by economics. And today, mass burn waste to energy facilities, because the energy prices are so low, are focusing their efforts to recover materials. And so for advanced thermal treatment technologies like gasification and pyrolysis, while there are private investors to try to move them forward, the deployment is very, very limited because they must be economical on their own, whether from the gate fee or the sale of their product. And really, the gasification scenario in North America is quite precarious. There is Enerchem, which has proven that they can make money by selling the appropriate methanol or ethanol, so they have to follow that market. But other types of fuels or gases are not economical. And the interest is starting to develop in pyrolysis because, again, the market is looking at getting these oils from plastics to make high quality plastics again. So until these technologies can all be profitable on their own, waste to energy will dominate in the United States, mass burn. It will be focused on recovering more materials, such as critical materials and so on. And unfortunately, landfilling will be dominant, again, because that is the lowest cost situation. So that's really the scenario in the United States, is the focus on the economy, because each municipality pays for the removal of their waste, and there is no subsidy here.
Thank you for your last comments. I would stay here for 100 more hours and hours, but I think we already exceeded the time we planned in the beginning. So let me thank you for your availability to take part of this talk and for the interesting discussion. And I really would like to have future occasions to discuss further on these and other specific topics, as also Umberto suggested. So maybe this is the first of a series of meetings of this kind of this podcast. So I'm also to say that I'm very happy and very glad that in 2 weeks we will have the possibility to meet and discuss again with maybe a bit more time or maybe less, I don't know, about specifically the role of thermal treatments in the circular economy, as this is a planned focus session on Tuesday, 22nd of November, within the Venice conference, which is the 9th International Symposium on Energy from Biomass and Waste. And you know, this will be held on the 21st, 23rd of November in Venice. So I want to thank you all again and see you there. Thanks a lot. Have a nice evening.